Okay, if you were in chapter 3, you would remember us graphing or doing something similar. I'm just making this up. Do you remember this?
No.
Yes.
I do.
What's the parent function?
Oh.
Square root.
Aha, so you can do that. So the parent function was the square root of x. What is, if you were to graph this, just, how would you do this? How would you graph it?
It's like a.
6 is your line.
It's like a that. It's like a line.
It's like a line.
Well, you
it's
use
like-
numbers that are like
Yeah.
good.
Looks like that, right?
Yeah. You use like
I could have
9.
told you.
So how about starting with 0? What are, give me, can I have 4 numbers that I can take the square root of?
9, 4,
1, 4, 9,
9,
16.
1, 4, and 9. Let's just stop there, right? So, if I said, hey guys, graph this problem, do you remember what to do?
You plug it in the calculator.
What was the first thing that you had to do?
Turn on the calculator.
Anybody remember? Because this is what we're doing today. But not with this function, with exponential. What did you have to do?
Oh, you did like
You had to plug
horizontally
do stuff.
compress.
So then the
Multiply by
2.
2.
Huh?
Multiply by
Huh?
You take out the 2.
Oh,
and then it's
okay,
X minus,
take out the 2.
it's X
That's
minus
fine.
2.
Do good on that shit.
X what?
Yeah.
Matt,
Minus 2.
X minus 2. Okay, so, first, do you remember how to describe the transformations?
Yes.
What was the A value?
The 2. The 2 is the A value.
The A value was the 2.
That's all I know.
Do you remember what you had to do? You had to flip that number, flip it, you get 1/2. So you'd say horizontal compression by 1/2.
Yes.
Now, do you remember what to do on the T-chart to do this operation? Horizontal compression by 1/2. Do you remember what to do?
That's the X.
You multiply the X value by 1/2. Remember this? Do you remember what B is?
Negative 2.
So you're gonna, 2 units to the right, and what you're gonna do here is add 2 to your X's. You remember what C was? Where do you go from here? There's C. Reflection over the X-axis, and D would be vertical stretch by a factor of 3. Do you remember how to do C and D? One step. You multiply the Y value by -3. And the last thing, 6, you're gonna go up 6, and do you remember how to do this one? You're gonna add 6 to the Y value. We did this in chapter 3. Do you remember this?
Yes.
Okay, so what are you doing today? We're going to do, the only function we did not do when we did this section was exponential functions. You're gonna take, this is an exponential function. What you're gonna notice is it has X and Y in it. What do you notice about the positioning of these 2 variables? What do you notice? The X is the exponent. Like you're not seeing this problem, right?
No.
Right? And you're not seeing this, right?
Right.
So you're always gonna see in this set, the X is gonna be an exponent. Now, what are the kinds of things that they're gonna do to this? They're gonna take and write -3 times 2 to the 3x minus 12 plus 6. These are the things you're gonna do, yes? So this is gonna be your A value. You're gonna have to pull this A value out. This is your parent function. Your parent function is y is 2 to the x power. You're gonna do A, then you're gonna do B, then you're gonna do C, then you're gonna do
Can you
D.
do those charts there?
Yes, this is what we're doing. So, one of the things that I want you to understand, we talked about, the first thing I asked you was, what is the shape of this problem? What is the shape of it? You have to be able to recognize the function, the equation, in what family it came from. What is it gonna look like? Okay? It's like if you were to have a child, what would your child look like?
Me.
It would look like you would have a lot of the characteristics of you. So, this, if I asked you to graph this, it would resemble this, but it's gonna be shifted up, down, it's gonna be stretched, it's gonna be compressed, it's gonna be flipped over the X or the Y axis. You have to figure out where it's at on the graph. Likewise, I want you to look at these functions right here. Check out the very back where your homework is. Look at all these things that you're gonna have to eventually be able to do. This is tonight's homework.
Oh, wait.
Ooh.
So, I need you to first be able to find the base, the parent function. So, checking out 15. Can you tell me what the parent function is on this one? Would everyone be able to pick it out? Y equals 2 to the x. If the base is greater than 1, it's a growth problem. The graph, the parent function will look like this. So if A is greater than 1, A meaning A is your base. Think of A as the base. A is the number that is attached to that variable, that x. That's what's raised, that is what they use to raise x to that power. So if the A value is greater than 1, this is gonna be an exponential growth problem. If A is a number less than 1, it'll never be 1, it'll never be 0. If it's somewhere between 1 and 0, here's 0, here's 1. So give me an idea, here I'm graphing 0 to 1. What kind of numbers am I looking for that's gonna be decay? Decay goes down.
Irrations.
What kind?
Irrations.
No, not irrational. What, give me an example of
Well,
some.
Like 1/2.
Yeah, like 1/2, 1/3, 3/4. What about 3/2? Is 3/2? No, that's bigger than 1. So you have to know, is this a growth problem or a decay problem? So does everybody understand, on the very front, we talk about which is which. For the first two in this one, these three, 10 to the x power, this is gonna be a growth, this is gonna be decay, and this is gonna be growth. Okay, everyone should be able to recognize if it's a growth problem or decay. Growth reminds me of, if I were to stretch this out, doesn't it look like a positive slope line versus a negative slope line? So can everyone do that for me? On the front page, I gave you the basics. If you see a big number, you're shifting your graph 2 units up here and 3 down. Do you recall what happens when you have a number underneath, like if I gave you something like this? What does this do? Shifts it 5 units
To the right.
to the right. Versus if I gave you something, this is shifting 3 up, this is 5 left. So think of the power has the same effect as something that's underneath or in parentheses, okay? What about when we had a negative number outside of the grouping symbol, way in front? Can you guys tell me what happens when you have a negative out here? Reflection over the x-axis. What about if there's a negative underneath? Reflection over the y. So those are easy, right? So let's start with a very simple example. Number 1. Very simple. I'm starting you off easy. If someone asks you to graph f of x is equal to 3 to the x minus 2 power. you better be able to figure out what the parent function is. This one is not y equals 2 to the x power. But I do know that to go from here to here, it's a shift 2 units right. So let's look at the parent function. How would you sketch the parent function? Well, you've got y is equal to 3 to the x power. You're going to want to generate some numbers that you can take 3 and raise it to that power. Give me like 4. Can you do 4? -2, -1, 0, 1, and 2. There's 5. -2. Does anyone know what 3 to the -2 power is? 1/9. Good. How about, and do you guys remember how to do that? Negative
No.
exponent? We'll bring it 1 over 3 squared. Okay, how about 3 to the -1 power? And 3 to the 0? And, so if we were to sketch this graph, and the next one's off the page, but this is not the graph we want. We want this one. Well, what is the deal to go from here to here?
Shift
You're gonna go 2 units right. So if you took these points, if you took this one for a little walk and went 2 units this way, and 2 units this way, and 2 units this way, and 2 units this way, what do we have? We have this graph. Now, what if I didn't want to do it that way? What if I just wanted to do it with a table? Do you remember mathematically how to play around with these numbers so that way you get this new y equals 3 to the x power minus 2? Do you remember what to do? You're going to add 2 to the x. This tells you you're going to add 2 to the x values. And if you added 2 to each of these, you would get, if you added 2 here, you get 0, 1/9. Add 2, you get 1, 1/3. Add 2, you get 2, 1. Add 2, you get 3, 3. Add 2, you get 4, 9. And that would be your new table. This is what we're going to do, but we're going to do it on a much crazier scale in a second. Just this one really quick. We're going to touch on this really quick. E is a number. It's if you take your calculator and you were to graph E. E is 2 point, actually, let me do this for you. Okay, clear. I'm going to show you what E is. E is 2.718281828. There's no pattern. It's not repeating. It's not ending. It's an irrational number. But we can't, it's just like saying pi. Pi is 3.14 and it goes on forever. So here's pi. There's pi. Pi, we stop right here because obviously our calculator screen can't go any further than that. So we just chop off this, usually that's what we do. We write 3.14. But do you realize you're losing the value of this actual number by throwing out all of these digits? And same with this one. E is about 2.718. If you lost all these, then you're just estimating. So now what they're asking you to do is I want you to graph e to the x plus 2. Well, what do you think is happening to your graph? It's shifting what? Up, down, left, right. It's going where?
Up.
Up where?
2.
Up 2. Now, how could you do this mathematically on your T-chart? What would you do? Add 2 to the y values. Let's see if it works. So I'm going to go to my table, and or my equation, and I'm going to type in e, and then I'm going to type into the x power. If I graph this, hit graph, there it is right there. Now if you hit second table, you can see all of the values. So 0, 1, and obviously for 1, they estimated, they rounded. Okay, now watch, if I type in on the second equation, e, whoops, wrong, second, e to the x, and then I'm going to do plus 2 and graph it. What do you think's happening? What did it do? It shifted your graph 2 units up. This, believe it or not, it's so close to the x-axis here that you can't see it. It just blended in. I don't want you to think that it stopped right there. It's just because of the technology. If I blew the screen up, you probably, if I change my y value screen to, let's say, 0 to 1 or 0 to 3, you would see it much better. Now let's look at the table of values between equation 1 and 2. Was Troy right? Did you add 2? Does it look like these are all added 2? Yep, and that's exactly what you do. So now that you're smart and you can handle, and this is, what class is this? Pre-calc? We can do, look at how ugly this equation is. I bet you guys can do this without a calculator, right? Without a calculator. So, take a deep breath, and what's your first step? What are you first gonna do? A, but what should I do with this equation?
Rewrite it.
Rewrite it. Why do you want to
Chelsea.
rewrite it?
Bring that 1/2 out.
You want to take the 1/2 and factor, and that is your A value. How many of you can successfully tell me what B is?
X minus 2.
Very good, because I had quite a few students say, I don't know how to get the B value. What you do is you divide that. You're going to do -1 divided by 1/2, which is going to make that -2. So now, everybody see, I'm going to refer, this is your A value, this is your B value, this is your C value, and C, we've got 2 things we can do, and this is your D value. Now, for A and B, what does A and B do? A and B affects the X value. And C and D affects the Y value. These 2 affect Y. And these 2 are X. It's hard to read that, but. So these 2, so what you're going to do, after we list the transformations, you're going to do these 2 things to your X value and these 2 things to your Y value. Is this coming back to you from chapter 3?
Yeah, it's just getting
But we
better.
just did them with different types of equations, so let's start. Can you tell me, we're going to first list the transformations. What would be the first thing you're gonna say for A? Is it a vertical stretch, horizontal compression, 3, 1 to the right, 2 to the left? What is it? You start with this right here. Do you remember what to do with this thing? What would you have said in this example that I started off with? What would you have said? You would have said a horizontal compression by what? 1/2. What will you say for this?
It's a horizontal stretch.
You would say a horizontal stretch by a factor of 2. So I want you for A, horizontal stretch by a factor of 2. Now how do you do this this A? You're going to multiply all your X values by 2. Not that, you flip that one. You're going to multiply them by 2. Okay, what's the next thing you're going to do? What's B? -2. This is going to be 2 units to the right. So you're going to add, for this one, you're going to add 2 to your X values. Then you go to C, and there's 2 things you can do here. This is going to be a reflection over the X-axis and vertical stretch by a factor of 3. Now, how do we mathematically do C and D now for this one? You multiply the Y values by -3. So this one you're going to multiply Y by -3. And the last thing you're going to do is shift your graph 4 units up. And how you do that is you're going to add 4 to your Y values. So 4 up, you're going to add 4 to the Y. So now, how are we going to do this? Let's start off with, I need the ordered, what's the parent function? There's your parent function. right there. So I need you to give me some good points. -2, -1, 0, 1, 2. So 1/4, 1/2, 1, 2, and 4. So what's our first operation? What are we gonna do? You're gonna take your x value and you're gonna multiply it by 2. Multiply the x value by 2. Because that's 1/2, you flip it. So you're gonna multiply, what x values am I talking about? These ones right here. So if you multiply all of these by 2, you get -4, -2, 0, 2, and 4. What do we do with these y values? You keep them the same. Everybody with me on that? Okay, what's the next step you're gonna do? We're going to, this is gonna shift your graph 2 units right, so we're gonna add 2 to your x's. What x values am I talking about? These ones. We're gonna take the x values and we're gonna add 2. Tell me what you get for the for the new values. You're gonna add 2 to all these. So you get -2, 0, 2, 4, and 6. What happens to your y values? They stay the same. Now we move on. So these 2 are the x's. These 2 are the x's. Now the next 2 are the y's. These 2 are gonna do the y's. So y. What do you do next? Move out in front. We're gonna multiply the y values by -3. So we're gonna take -3 and multiply the y values. So tell me what you get. Now think, I'll do that because my eyes sometimes wander. So if I multiply, I could write this to make sure I don't make a mistake. That's not guaranteed to not make a mistake, but if you multiply all these by -3, -3 times a fourth is -3/4. -3 times a half is -3 halves, or -1.5. -3, -6, -12. And then the last thing you're gonna do is add 4 to those y values. Add 4 to the y values, y plus 4. What y values am I talking about? Well, they're these ones right here, x and y. So keep your x's the same. Now, if you add 4, so think of this as -0.75. This is going to be 3.25. This is going to be 2.5. Add 4, you get 1. Add 4, -2. Add 4, you get -8. So what you're going to do now is you are graphing this last set of numbers right there. You're graphing those. Let's look at the parent function first. The parent function looks like this. But the real deal is over 2 up 3.25, over 2 up 1, 2, 3.25, over 0 up 2.5, over 2 up 1, whoops, 2, 1, 4, down 2, and 6, 1, 2, 3, 4, 5, 6, 7, 8. So it looks like this. That's what your graph looks like. Questions? So, for your homework today, for the first 13 problems, what you're doing is describing the transformations. So 1 through 13, you're just going to say, if it's shifted vertically up 5, stretched, whatever that is. And then for 14 through 18, you're gonna do exactly what we just did on that last problem. You're gonna graph, do the parent function, pull out your A value and use your chart as necessary. Some of you can do the whole graph in 2 columns. That's fine. Sometimes you'll do the X's first, and then you'll go back and then do the Y's. But I included all 4 just in case you wanted both of them. Okay?